Well, hello, everybody. This is Scott Roberts here, and I am here with Dr. Alan Stern. And I have to tell you that this is kind of a big moment for me because I'm a huge fan of his, and so we're going to talk a little bit about his background. I'm going to hopefully show you why I'm so fascinated by this gentleman. He is really what I call a Renaissance explorer. This is a guy who understands all these complex facets of many different disciplines in order to get things like spacecraft out to explore the planets and to do, to be the lead guy on so many of these missions and to develop the instrumentation that is helping us explore our solar system and ultimately to understand our universe. And Alan, how are you today?
I'm good, Scott. Thank you for having me here. I'm
That's
excited
great.
to have a
Yep.
conversation.
So I confessed to Alan a little bit earlier that I was nervous, and he said, "Look, Scott, it's just Alan and Scott, and that's all it is." So, but I thank you for that. You are someone that you're not only this great scientist, but um, you are someone that is very concerned about getting educational outreach about what you do and what these missions are all about, and to help the general public understand where we're going. Because in my mind, I believe that we have become a spacefaring species. We have people in space 24/7. We have our appliances all over the solar system. We've got spacecraft, in interstellar space. We can no longer say that we're just an earthbound species, okay? And there's no other animal in the certainly on our world that can claim that. So, at least to my knowledge. But just a little bit of background about Alan. Most recently, he was appointed by NASA to be the first ever researcher to fly as a crew member aboard the Virgin Galactic suborbital spacecraft. And I think that is you're probably the first researcher to fly aboard any privatized spacecraft. Is that true? Will that be true?
I think that's the case. That's right.
Yeah. Yeah.
Right.
And, and I know that you are certainly a fan of privatized space exploration, and you believe that through privatized space exploration that it will help leverage governments and what they can do, probably intergovernment relations as well, and but all the while strengthening the privatized sector. And I can only imagine the kind of spin-off technologies that we will have from all of this, because we watched what Apollo did, certainly the space shuttle missions and what they did, even projects that have gone on since that time. But I think that the synergy of privatized space exploration and governments can really take us to the next level. And I think you think that way too.
I'm excited about it, Scott. I'll tell you. I think the private space revolution, and that's not too big a word, is something akin to the revolution that we saw in computing when we went from mainframes to PCs.
Hmm.
And we saw prices drop, the machines shrank, and yet their capabilities exploded.
Right.
And the degree of innovation that we are seeing in private space flight by having multiple companies developing the same things different ways is very healthy, and it's really put the pedal to the metal
Yeah.
on human space flight and the launch business and the Earth observation business, and now the communications business, and soon I hope the business of doing science. And we're going from a world where space flight was rare, just like computing was in the early decades after the computer was developed. From rare now, like computing, spaceflight is becoming routine, and
Right.
it's going to be with us for the rest of civilization.
Yeah, we're not turning back. We're not going to go back into the cave or anything. It's only going to become more of this. And certainly, with humans inhabiting space. I kind of wonder though. I believe that we're also on the verge of artificial general intelligence, or the next level of artificial intelligence. And I kind of wonder, we were talking about Buzz Aldrin a little bit earlier, and he and I had a conversation about exploring other star systems. And he said it won't be done by humans, it'll be done by artificial intelligence. What happens? What do you think, or how is artificial intelligence now working with spaceflight systems and our current exploration of space?
Well, we're in the very primitive days on that.
Mhm.
Very, very little in the way of AI is aboard uh, any spacecraft
Mhm.
until very recently. And now some of the commercial spacecraft, and in a few cases, scientific applications, and that includes on the ISS, are beginning to have some early AI capabilities, primarily in my experience in machine learning.
Right.
But I think that the cognitive assist that's going to develop over just this decade in the 20s is going to be very powerful. And we're going to see it infuse its way across the flight segments of virtually everything that's built going forward
Right.
by the end of the decade, not immediately, because we're not quite there yet. But up until recently, we didn't really have the compute power on board spacecraft to do this kind of thing.
Right.
And so even though we could put it on the ground systems or benefit from it in the scientific enterprise, like research problems, analyzing large amounts of data from scientific spacecraft, we really couldn't put the code up on the birds or give the birds connectivity
I
to something like the cloud on the ground for a number of technical reasons.
I see. I see. Sometimes I believe that we're further along than maybe what we are. I mean, just some of the amazing things, where we were able to reboot things from JPL, where things had failed, and our spacecraft had gone into, or our rovers had gone into safe mode or something like that. It's amazing to me what they've been able to do. But
And we do put what are called autonomy, fault protection, and autonomy systems on robotic spacecraft that can detect through sensors and logic and detect and diagnose various failure modes,
I see.
and then actually run down a checklist and even branch in a checklist like an astronaut would.
I see.
If the
If
valve
this
is
and
turned
that.
this way, that thing.
Right.
And that gives them a lot of capability. It's very important, particularly on missions that are remote across the solar system. And I don't just mean New Horizons, which is very far away, but even minutes away can make a difference. The spacecraft has to be able to take care of itself for time critical problems.
Very interesting. Uh, let's uh, let's go back to let's go all the way back, Alan, before we get into New Horizons and your work with you've got a program going on with the moon. You have, I think, probably at any one time, you must be like a whirling dervish that has all these projects going on at the same time.
Maybe not that frantic, but yeah, there's too little
It would,
time.
it would seemingly so, But anyways, but as a boy, did you have a deep interest in science? Who influenced you, in your
I
life?
did have a deep interest in science and in the exploration of space as a
Hmm.
boy. And it's really the only thing I ever wanted to do. And that might mean I'm in my childhood, the very first space missions were taking place, human space flights. I
Right.
don't remember things like Mercury, and I just have a few inklings of the Gemini program, but I remember Apollo pretty well
Oh yeah.
as a kid, and then very well by the time that it ended, because I was a young teenager at that point,
Yeah.
and it just swept me off my feet. And between that and movies like 2001: A Space Odyssey, I could do the math and say, when that movie, when the real 2001 happens, I will be solidly in my career, and I can't wait to get to that point.
Oh,
And,
sure.
and so it was the only thing I ever wanted to do, and I tried to learn as much about it.
Okay.
And my parents were pretty skeptical, to say the least, because in our family, people had done very different kinds of careers, nothing scientific or engineering related.
Sure.
But nonetheless, my role models were the people I watched on television,
Hmm.
Apollo astronauts and engineers and scientists.
Carl
Of
Sagan and his
course,
Cosmos.
yeah,
Yeah.
all those people,
Mm.
and some science fiction authors like Arthur C. Clarke and Ray Bradbury, who are also fantastic commentators and
Right.
futurists. And when I was very young, uh, I remember most of my friends wanted to grow and be involved in space exploration. And as we got older, it got lonelier and lonelier. By the time I got out of high school, I was like the only guy in my class that I knew that wanted to do something like that.
Really? Huh.
But
Okay.
then when you go to college, you make a concentration. And I found in physics and astronomy a lot more people again, that were like minded. That's why they went into those fields. And then I was an aerospace engineer in grad school.
That must have been like a breath of fresh air for you
Um,
at that time.
Absolutely,
Yeah.
absolutely. But I was very disappointed as we were growing up, going through adolescence, to see all these people peeling off for other
Right.
pursuits that I couldn't imagine would be nearly so exciting. A lot of them seem like they'd be like a grind to do for 40 or 50 years.
Yeah, Alan, we work a lot with kids that are interested in science, and we encourage them. We do a recognition award with the Astronomical League is one of the things that we do. But I talk to these kids, and sometimes I have them on the show. And before we go on the show, I'll talk to them just so I kind of get to know who they are a little bit. And a lot of them have this experience of where their friends won't don't want to talk about these things. They don't want to explore these kinds of ideas.
Why is that?
I honestly don't know. I mean, this might be one reason. I mean, we're Apollo kids, so we were absolutely fascinated. They were rolling the black and white TVs out into the hallways. We were watching the launches. We were seeing the impossible happen. Okay, when they set foot on the moon. I mean, it was just I can't even really explain how mind blowing that was. We'll experience it again when we go to Mars, I suspect. Okay, we go back to the moon, it will still be a huge, huge event, but not like the first time we went to the moon. And so I think that these kids, first off, have an intellect that is higher. I think they're more focused than a lot of other kids are. They're willing to work hard for it. They have a direction, you know. And one of the kids that's on our show, she's 10 years old, and her name's Libby. And she says that once she got interested in astronomy and space science, she went through every book in her library, in her school library, read them all. Okay.
I did that. Guilty.
Right. Right. So, yeah. So I was,
I was the nerd that spent my weekends at the public library.
right. Right, because all that knowledge was there, and just that voyage that your mind would go on and everything. So,
And I remember, this is an old technology, but I discovered that the main public library in the city I was growing up in, Dallas, Texas, had much more than just the collection of books. They had countless numbers of space program documents on a technology called microfiche
oh, right.
film.
Yeah, yeah, where you had the
Put it on a
machine
viewer,
and
on a projection viewer. And all of a sudden, there were literally thousands of NASA technical documents that you had access to.
hmm
I was hopelessly strapped to that library for a couple of years.
Well, I love the library so much that I volunteered to work in it and shelve all the books and all the rest of it. Went through all the National Geographics until, from some of their first publishings. It's so fascinating. And there's so much information out there. And we are now in this golden age of information, huge amounts of data. that you can find at every level. You can find also that there's so much data out there that we're having a, that the pros are having a difficult time reducing it all. I remember when the first infrared IRIS spacecraft went up, and they said at the time that it would take something like 60 years or something like that for the professional community to digest what IRIS had collected in his surveys. And so, and I imagine that the same thing is true for New Horizons. I imagine there's so much data that's been collected that a friend of mine, Linda Spilker from the Cassini mission, she said when the data came out, she said it was like a fire hose. She said there was just all they could do was just skim the surface of what was coming out.
And the analogy that I make, and we had the same experience, was that it was like being doctors in an ER, in an emergency room, where all we could do was triage the data sets as they would come down.
Right.
As you say, skim them, or as Linda said, skim them, and get the cream, and then move to the next patient. And they were coming in that rapidly. And it was only a couple of years later, when we had everything, we could start to seriously do the science and actually do the careful modeling and the much more involved data reductions that really brought all the power out in those data sets.
Sure. We have people here on live chat with us, Alan, and let me look at and see if there's any questions. If there are no questions yet, feel free to ask Alan anything that you'd like to. We are sticking with science, and so and the missions, but Alan is willing to take a wide range of questions. And let's see, we have someone from Kosovo watching. The Astronomy Club of Kosovo is watching right now, so that's cool. We have Tracy Prell is watching. She said, two amazing friends, Scott Roberts and Alan Stern, who enjoy exciting and inspiring the public in science and space exploration. That's very kind of you, Tracy.
It is, yeah.
And people are talking about how Arthur C. Clarke was such a big influence on their lives. So, when you go through this whole process, you must have also had a lifelong dream of, flying in space, I would imagine. This NASA decision to put you on as a researcher above Virgin Galactic, I think is huge. But you were also considered for crews aboard the space shuttles, I think, a couple of times.
Right. I interviewed, was a finalist to be a mission specialist. Interviewed NASA Houston, went through all the medicals and the psychological exams. In fact, that's how I met Mark and Scott Kelly.
Okay.
Actually,
really? Okay.
Interviewed the same week, and we palled up back then. Now he's in the U.S. Senate.
Oh, right.
But anyway, he got the job and I didn't. And a little bit later, a few years later, I was selected to fly on a shuttle mission as a payload specialist with my own experiment to look at Comet Bob. But that ended up not happening because the NASA administrator of the time bumped my position to fly an international deal where they had a bilateral agreement with the Canadian Space Agency.
I see.
That was heartbreaking in a way.
Yes.
But lots of other good things have happened in my career, and I'm glad that I'm now really headed to space.
Right. Yeah. Finally. And how do you feel overall about the Virgin Galactic program?
Well, I'm really looking forward to it because, we talked about spaceflight becoming routine, and we actually have 3 seats on Virgin Galactic now for experiments. So I'm looking forward to flying quite a bit.
That's awesome. That is awesome. And there's been questions about the safety, the safety factor of flying into space. Of course, flying into space always carries a risk. Is this something that crosses your mind? Is this, are you more thrilled with the adventure of it? Or this is something that I think for you, this is something you had to do in your life, you know?
Um, I can't deny that, but I'm interested in it for a lot of reasons. I'm interested to go and actually be a worker in space. I'm interested to see our planet from space.
Yes.
Spent a lot of time in zero G on zero G aircraft flights, hundreds and hundreds of parabolas. But there are always little snippets at 20 and 30 seconds at a time.
Right.
I'm looking forward to getting some more hang time than just tens of seconds.
Yeah.
And
I hope that you don't go through so much training that's just, yeah, as Buzz Aldrin told me, he said it was so much muscle memory. He said it didn't seem really any different from training, you know?
that's kind of how I felt about when I was flying the F-18s
Right.
and U-2 type aircraft and F-104s. The training really, it was exciting, but not as exciting as I would have thought as a child.
Right.
Uh, and I wasn't in combat. We were doing a lot of a fair amount of supersonic, but mostly straight and level because
Right.
we were doing flight experiments. And we have one or two hair-raising moments over the years that make good stories. But I am quite realistic about the risks. I am now probably one of the few people who can say that I was actually there watching the Space Shuttle Challenger when it exploded.
Oh, yeah.
And I had both my first PI experiment aboard and the first time I was project scientist on a satellite, and they were both destroyed by that, including 6 of the 7 people on board who I knew.
You knew them. Yeah.
And so I grappled with that reality of risk quite a long time back.
I see.
And made my decision that I accepted it.
Right.
I think these systems that are being prepared for commercial spaceflight are going to be far safer than the space shuttle. That may be akin to 1920s aviation,
Okay.
which was relatively safe, but by today's safety standards, no one would stand for it
Right.
in terms of the flying public. So
Sure.
I think for a while, space flights, particularly all forms of space flight, are going to be comparatively risky compared to getting on an airplane
Oh, of course.
by orders of magnitude, but not as risky as going into combat.
Mm-hmm. Mm-hmm. Right. I understand that. Um, uh, you were the you are the PI, the principal investigator for New Horizons, but there were steps leading to that mission. If we can just kind of segue over to Pluto a little bit.
Mhm.
Um, uh, I want to ask you, your thoughts on Pluto, but I want to go back to kind of the earlier parts of what led to New Horizons. I saw projects like Pluto 350 and the Pluto Kuiper Express. You were involved in all of that, right?
All of those. Yeah, I was
Right.
the project scientist for Pluto 350. That was the first serious NASA study of how to do a mission to Pluto.
Hmm.
And then I was in charge of the NASA Outer Planet Science Working Group that was responsible for steering decisions of which missions we would fly. I chaired that. Uh, uh, and all of the Pluto mission studies came through us. So I was very deeply involved in all the precursors to New Horizons. But
Oh,
none of
wow.
them ever made it off the drawing board. It was very frustrating.
I could
On the other
imagine.
hand, the mission we got was better than any of those in the end. And, it wasn't commercial, but NASA conducted a competition on very short notice. They actually announced that competition the third week of December in the year 2000, which I'm mindful of is 20 years ago next week.
Right.
And with almost no notice, we had to pull together teams and put together a study of how to do it and propose it to NASA the following spring in 2001. And
Why would they give such a short timeline
well,
for
what happened?
something?
NASA had conducted this whole series of studies and spent a lot of money
Yeah.
over the decade of the 90s. I think the agency spent about $350 million, which is about as much as it cost us to build,
Yeah.
test, and launch New Horizons. So that was a lot of money. It was spent, you know, small amount each year by divide by 10.
Hmm.
But there were lots of studies, lots of engineering work done, lots of work out in the scientific community. And every one of these was befallen by some problem, usually management problems. That the
Okay.
cost would explode and NASA would throw its hands up and say, "Oh, we just can't afford to do this," And the fifth time that it happened, or maybe it was the sixth, which was in the fall of 2000, um, the then NASA administrator for science, Ed Weiler, held a press conference and said, "That's it. We're stopping work. We're not going to do Pluto. We're not going to talk about it for 20 years.
Oh my God.
It is dead, dead, dead." And we tried every way we could think of, and it didn't work out. So that's in the review mirror. And those of us who felt strongly that it was entirely feasible if it was done the right way,
Hmm.
put up a lot of fuss.
Hmm.
And in the scientific advisory committees, in the science community in general, letter writing campaigns, the Planetary Society got on board. They got 10,000 letters to Congress. People were literally walking in front of NASA headquarters every day, holding up protest signs to fly missions to Pluto. There's something about that
That's
plan.
awesome.
And maybe it's the frontier aspect,
Yeah.
and maybe it's a little bit of unfinished business that Voyager had been all the way to Neptune, but not done the next step. And at that time, that was the most distant known planet. And
Right.
NASA relented in a time between September, when they said it's dead, dead, dead. We're not going to talk about it for 20
I
years.
see.
And early December 2000, they decided to give it one more try, to just throw it open for competition and see what innovation could bring, with the caveat that if they didn't find something they liked, they wouldn't do anything. And if they selected a group and the cost got out of control again, or some other deep problem came up, they just canceled it.
Hmm.
So I got phone calls asking me to lead that from the Applied Physics Lab,
Hmm.
Johns Hopkins, and from the Jet Propulsion Lab, and I decided on APL. We were talking about this. The story's in the book New Horizons,
Right.
Chasing New Horizons.
Right.
Quite a
Buy
story.
this book, by the way.
Thank you. I call this my 100 lost weekends, getting this thing written. 2 years for David and I to do it.
Oh man.
But NASA decided to compete it. But
Yeah.
because the only real tractable way to go to Pluto was via a Jupiter gravity assist, the timing was exquisitely tight. In order for Jupiter to do the gravity assist, it has to, if this fingers Pluto way out in the distance,
Okay.
Jupiter has to be coming around its orbit to be along the direction to Pluto.
Sure.
And that
It's
only
really
happens
shot it out that way.
3 years out of every 12 that it takes Jupiter to go around. And here we are late in the year 2000. And the Jupiter launch windows in that decade were in 2003, 4, and January
Oh my
2006.
gosh.
And then forget it for another
Right.
9 years. So
So you're
NASA
starting at zero, at the 0 point, right? You don't have
had to go
a
look at
single piece of hardware built. There's nothing.
we didn't have a design, we didn't have a team, we didn't have anything. And a proposal was due 90 days after NASA's call for proposal.
Wow. Wow.
And then,
Well,
it was very fast selection. There was a phase A study in between, and then we were selected at the end of November 2001. And then we only had 4 years and 2 months to build it. And by comparison, Voyager, Viking, Galileo, Cassini, all those spacecraft of the time were typically 8 or 10 year developments. And they had 5 times the money for Voyager that we had to figure out how to do New Horizons very inexpensively. So there were a lot of challenges. And fortunately, the team of people that came to be New Horizons were just not only incredibly talented and the pick of the litter, but incredibly dedicated. To around the clock, 52 weeks a year, nights and weekends, whatever it takes, we're going to get this thing done. And they did. It's an amazing story of American determination and can do.
right. Now, you're also known as someone that got things done on time, under budget. And you're also have been openly critical of people that have or divisions that wasted money. Okay. where, and this happens in companies too, where one department is sucking up all the money from another department, and just because there's some sort of favor of whatever reason, okay? Um,
You
but they're
know,
not, maybe not looking at the big picture of the health of, you know,
Scott, in the late 2000s, Mike Griffin was NASA administrator,
yeah,
and he asked me to come and run the science program at NASA headquarters to be associate administrator, science mission director. I didn't dress like that in those days. I wore a suit to work every day. But
you did.
it's a $5.5 billion program
Yeah,
with all of the research grants. And at that time,
3,000 grants or something.
yeah, and we were managing, in addition, 90 flight missions, about half in development and about half that were actually flying and returning data.
Hmm.
And unlike a private business, I can't go out and get a loan for more money. I can't
Nope.
go out and print more money. I can't go out and sell more. My budget's fixed by Congress and the administration. It's a zero-sum game. We all have to live within it. And the problem is when a mission gets out of control on cost in a zero-sum game, the only way to fix it is to delay or delete other missions.
Hmm.
So in effect, what happens is when you have errant missions whose cost balloons, um, to solve their problem, in other words, to reward the guilty, if you will, who
Right.
have caused the problem, you actually have to punish the innocent, the projects that didn't cause the problem, and delay them or delete them, as I said. And that doesn't seem fair. That doesn't seem the right way to manage a portfolio. The
Right.
right way to do it is to help projects stay on price, so that and to properly price them to begin with, so we're not kidding ourselves about what it will ultimately cost. And there were some famous examples of mismanagement going on then. I think it's a lot better now, but back then there were some famous examples of mismanagement, and I was working hard along with the staff there at Science Mission Directorate
Hmm.
to get those in the box, and to create a different psychology that would generally keep projects on cost. We were spending about one in every $5 on overruns. So if you think about it, if you can then stop that, you can do 20% more good stuff.
Right.
So why wouldn't you want to do that?
Right. Right. Now, I think that you and your team, during that time that you held this position, that you affected some fundamental changes at NASA in the way that they look at science missions. Um, what is still lasting, or as you see it from your time being at NASA,
Well, I think there are quite a number of things. There are a lot of missions that are flying.
right?
We started, and a lot of missions that we helped manage through. But realize spaceflight is a team sport, and most spaceflight projects take many years in development, and
Hmm.
they're gestated even before that, and then they have a flight mission. So a typical flight project life cycle can run 10 years, even for Earth orbiters, much less far away missions that have to travel a long way, like New Horizons. So a lot of those are still flying today, but many other people besides those who were in office when I was there, before and after at NASA headquarters,
Hmm.
get credit too.
Oh, sure.
Working on those problems and
Right.
solving problems every day.
Hmm.
Um, but there are a lot of other things that we did. We placed a much higher priority than previous folks had on the data analysis. I used to say that you can send all the ones and zeros to the ground from these amazing missions like Hubble or a Mars rover, but they
Sure.
don't mean a thing unless scientists, human beings, get paid to analyze that data.
That's right.
And that's actually soft power projection for the United States, because then we lead the world in the discoveries.
Right.
And NASA brand is everywhere in school books. Just say the word Hubble, and it's brand advertising for the United States and NASA. And you could say that about a lot of other space missions, like Voyager, and probably New Horizons, and many, many more.
Right.
Um, we also put a greater emphasis. In fact, I was very proud to select the first woman to PI a planetary mission, and the first woman to PI an Explorer mission.
Great.
and first woman to PI a space physics mission. And now that's become, fortunately, a much more of a level playing field. Instead of
Yeah.
breaking glass ceilings, we've now
It's now normal.
a whole cadre to where men and women compete evenly now, much more so than in the past, and to the greater good. I could go on, but I won't.
Sure. I think one of the, you brought up another point to me, or from watching your videos and some of your talks, I did not realize that it has been the United States that was first to visit every planet in our solar system. And you were giving recognition to that, and as a United States citizen, that is a sense of pride. It makes
And
me wonder why other countries didn't do this a long time ago.
it's not just a technical achievement. It's really a credit to all those Congresses and administrations that supported
Right.
the United States space program through NASA in doing this. And now the answer to your question is, in the early years, it took superpowers to mount these missions.
Sure.
And only the Soviet Union and the United States could compete.
I
And
suppose.
we're first to the moon, which technically is a planet. So I guess we're not first to every planet in the solar system, but the classical nine,
Yeah.
the United States was first to each of those, starting with Venus in 1962 and Mars 2 years later, Mercury and Jupiter in the 70s, and then on to Saturn and the ice giants, primarily in the 80s.
Hmm.
And Pluto finally in 2015. It was about time. But as you know, there are a lot more planets in the solar system than the nine we used to know about, because we have such better telescopes and detectors and software to do the work of finding these needles in a haystack, these
Right.
faint embers so far away. And the solar system is really begging for a lot more exploration, which NASA is looking at innovative ways to do that. But now we're in the happy position that many other countries have the ability to get involved in planetary exploration.
That's
And
true.
so we see European and Asian countries doing it. Middle Eastern countries are the first Middle Eastern mission is on its way to Mars orbit in just about 60 days.
Right.
Give or take. I don't have the date in my head, but it's the middle of February. And that proliferation is going to continue. And then we have the capability now that there are even private companies that are starting to offer private missions
Right.
to the nearer planets and to near Earth asteroids and the moon. So what we're going from is from only having more or less two airlines, NASA and the Soviet Union's equivalent, to having
You got some
very
competition now.
diverse, very
Yeah.
diverse ecosystem. And
Yes.
I think the human exploration is going to go the same way. It's tougher, so it lags behind what we can do with the robots, but it's coming. And the privatization of low Earth orbit, and I include in that this kind of missions that I'm going to fly on suborbitally, are now opening up. And a decade from now, we'll probably see first private missions sending researchers and maybe tourists out into cislunar space. I'm quite
Right.
confident in that.
Yeah. Oh, that's really interesting. Let me find some. There are questions here in this chat. Maybe you want to get something to wet your whistle there.
Okay.
I
You
have
gonna
some
take a break for a
coffee.
minute?
Let's see.
Okay, let's stick with it.
What's that?
We're good.
We're all good. Okay, that's good. Um, Question for Alan. Are you planning on another mission to explore Pluto or another planet?
So I am very fortunate currently to be involved in two flight missions that are in development. Not leading either one, but one is called Lucy, which is the first mission to the Jovian Trojan asteroids that hold important keys to the origin
Uh-huh.
of the giant planets and the Kuiper Belt. And that will launch next October. And then fly its flybys, a total of 6, from the mid 20s to the early 30s. I'm on the science team of that mission. And then I'm also on the science team for the Europa Clipper, which is a very large scale, what we call a flagship mission to explore that ocean world in the late 20s or early 30s, depending upon when it launches and what launch vehicle it ultimately flies on. But I'm not involved in putting together a Pluto mission to follow up on New Horizons, but I did do the first post New Horizons study as PI of that study of how to do it.
Hmm.
And we do know how to do that mission, but it's probably a good mission for the next generation um, of people because by the time you build it, launch it, fly it, and because you have to get into orbit around Pluto, you have to do many years of braking. It's really a mission for the 2040s.
Okay. Wow. Okay.
And if I'm still working, then I hope it's not strapped to a desk, but doing something else. Uh,
Right.
but I am looking at PIing another mission in planetary science.
Okay.
And the one that I'm working on right now is still under wraps because of competitive reasons.
Okay.
So
Fair.
I really can't say much about it, but it's super exciting.
No, that's awesome. That's awesome. Ron Delvaux wants to know: are you involved in the next New Horizons encounter? It's out in the Kuiper Belt at this point,
I'm
I think.
involved in everything in New Horizons
Okay.
because I'm the mission PI.
Sure.
So the project reports to me in every respect through our management chain, but ultimately to me. Um,
Mhm.
and we are looking for another flyby target. We're down to about an eighth of a tank of fuel. Now, the
Okay.
good news is it took about an eighth of a tank to do the Arrokoff KVO flyby. So an eighth of a tank might sound a lot lower than you need to think of it. But because we're going farther and farther out the Kuiper Belt, the Kuiper Belt objects are farther and farther away, and that makes them dimmer and dimmer and harder to detect, find from the Earth.
I
And the
see.
Kuiper Belt is thinning out. So there's less and less of them. So we're trying with the biggest telescopes in the world, but the odds are against us that we'll be able to find another flyby target on the available fuel. We've got the power and the communications range, and the spacecraft is healthy to do it. But there's only so much gas in a tank, and there's nowhere out there in the Kuiper Belt to gas it up again.
Yeah. You can't
So
just like drive around till you find something, right?
no. So we're doing lots of other cool science,
Okay.
very important science, studying the Kuiper Belt using the telescopes on board as an observatory right there on the spot.
That's awesome.
And we're making other kinds of discoveries about the heliosphere. We have much more sensitive gear on board than Voyager had when it came to this region in the 90s. And
Right.
we've made discoveries about the heliosphere already.
This is this hydrogen wall that they've been talking
Well,
about.
more than just the hydrogen wall, also the charge particles, the cosmic rays, the pickup ions, which really dominate the pressure of the heliosphere out there.
Hmm.
We
Hmm.
were the first to detect those pickup ions, although they've been theorized for a long time. Uh, and we're also the first to carry a dust detector. And the importance of the dust is that it traces where all the hidden bodies are as
Okay.
a telltale. But there may also be a second Kuiper belt further out, which would mean that we have a long lease on life to look for targets while we're being an observatory, as long as we are miserly about our use of fuel. Because if we use it up, looking at everything every year, there
Right.
won't be at all left in the tank for doing a flyby. It only takes about a kilogram to actually do the flyby, and we're sitting on 13 right now. But to divert to the target is what takes the bigger propellant load. So
Mhm.
I call myself the fuel hoarder in chief.
That's great. Um, Another question: with the flyby of Pluto, did you get the information that you were after? Is there another body in the Kuiper Belt that you wanted to explore? Well, you already mentioned that you wanted to explore close up. But was I guess another way to think about it was you must have already had some idea of what you were going after. That's what you build the instrumentation to look at. Uh,
Very detailed idea. NASA made us propose, along with the other teams, to a list of things you must accomplish.
Mm-hmm.
And you had to show that your spacecraft uh, and your instrument payload were capable of doing all that, flying across the solar system, doing it all on budget and schedule, but then accomplishing getting the goods to be able to make all the kinds of imagery and spectroscopy and other studies that also required. They listed about 14 objectives. They said the first 3 were mandatory, and the further down the list you get, the more points you get, as long as you stay in price and schedule. We actually did 13 of the 14 items.
Oh, wow. Excellent.
So we're pretty good about that. We didn't carry a magnetometer, so we didn't check out whether Pluto has a magnetic field. But that was part of staying on price, is you can't afford to do everything.
Right.
And then you take those objectives, and they're very detailed. They're not just like make a map. They're like make a map with the following signal to noise and dynamic range and resolution and other characteristics. And you have to check all the sub boxes too for each objective.
Mm-hmm.
When you lay out a flight plan to do that, as you fly through the Pluto system at this blinding speed of 35,000 miles an hour.
Yeah.
100 times the speed of a jetliner. On a one shot, we're not going to get to do this right, for us on a second try. It's all opening night.
There is no second shot, right? This is just.
Yeah. So, but you lay that plan out, and we had, I believe, 460 different observations to be conducted of Pluto and its 5 moons.
Mm-hmm.
And we got every single thing we wanted to get. And this went through years and years of planning, but we got every single thing we wanted to get, with the exception of one thing that was caused by that computer reset that we lost, a search for new satellites of Pluto. We made several searches, but the closest search to Pluto didn't happen because we were in the midst of getting the software problem fixed.
Wow. Okay.
So I think that's.
I mean, that's amazing. The feeling of satisfaction that must have been with the team must have been so high.
Well, and of course, and many of these people worked on it from the day we started New Horizons in January 2001, and
Right.
They put 15 years of their life, and as I said, a lot of nights and weekends, routinely nights and weekends.
Oh,
For
yeah.
15 years, kids grew up, parents got old, life, big chunk
Life
of
happened.
career life in particular. And then Pluto just completely cooperated. The whole Pluto system turned out to just be a scientific wonderland,
Right.
way beyond our expectation. So it just couldn't have turned out better, in my view.
That is awesome. I wish I could have been just a fly on the wall when the first images were coming through and the first successful data was coming through and all the rest of that. Some of my friends that work at JPL tell me what that's like, and it's just euphoric. So
and there's nothing like it in the world. Part of the reason that I wanted to see a mission to Pluto, so sadly, from the start of my scientific career, was part of it was just self-interest, and all planetary scientists want to be on that first mission to a new planet.
Sure.
Right? Or a type of object. And Pluto was both, because it was not only the first mission to the Pluto system, but the first mission to a planet in the Kuiper Belt, to an ice dwarf, and a whole new type of planet, which turns out to be the most populous class of planet in the solar system. And who doesn't want to be on that first mission, where all the data is like taking candy from a baby? Everything is brand new. Everything is a discovery. And people compete very hard to be on any space mission, much less first mission, and then first mission to the farthest planet, at least at the time that we were getting this going, was just irresistible for all of us. And
Right.
and that helped.
Tantalizing. Yeah.
The engineers and the technicians and the project managers and everybody that worked on it, they knew they were doing something really larger than life,
Yeah.
You had lots of people that had been involved in many space flights, but this one was just ultra special. And they talk about it to this day, 5 years after that flyby. And the same for the Arrokoth KBO flyby, because it was so much more challenging technically. I'm very proud of the fact that the people who put their time in, saw it pay off so handsomely.
Right. Yeah. So there must have been a lot of nail-biting moments for you in leading this project. You
There's
know,
some of that.
I know that we go back to budgets and stuff. Were there times where the whole mission? I mean, you're so far into it, and now there's some sort of danger of having your budget completely cut.
In the early years, that was a persistent threat, and we had several near-death experiences, and we actually had enemies, people in the community who wanted to stop a mission to Pluto and do something else instead with that money, and they tried to get it canceled and came within, a hair of doing it twice.
Wow.
And we dodged both those bullets with a lot of work. We had technical problems as a chapter in Chasing New Horizons called Alligators in the Water. There was a point where we had so many problems. I knew we could probably solve any given one of them, but whether we could solve all of them within the budget and the remaining amount of time was really doubtful. And it was bewildering. You just had to get up every day and go work and,
Right.
and hope that we'll get through all these sticky wickets at once. And we did. And that's a credit to the people who made the team. And then we had, anytime you launch it and you only get one shot at the launch, everything's riding on what happens that day. And the same is true with the flyby. And that's
Sure.
this near-death experience we had on July 4th, 10 days before the flyby.
Yeah.
So New Horizons had its share of hair-raising and scary moments for political reasons,
Yes.
and for technical reasons, and just the risk associated with spaceflight, sending a lone spacecraft all the way out there to the frontier, something that had never been done before. The Voyagers went as pairs, the Mariners went as pairs, the Pioneers went as
Yeah, you had backup, right? So
and in many cases, Voyager, we were getting pretty good at it by then, so they
yeah.
both made it. But Mariner 1 and 2 launched to Venus, and Mariner 1 ended up an oceanography mission. You know what I mean? Mariner 3 and 4 launched, and only Mariner 4 made it. Mariner 6 and 7 both made it to Mars, but one of them was limping when it got there. And that's Mariner 8 and 9, the first orbiters. Mariner 8 didn't make it. Mariner 9 fortunately did. You had to take a lot of risk to want to be on New Horizons, because in 2001, you knew you were going to put a lot of time in, but you didn't know if in 2015 it was going to pay off. There's 1,000 ways to fail.
Oh my
And
God.
some of them through no fault of your own. Your
Right.
launch vehicle goes bad on you.
Right.
Or the people that want to fly another mission just triumph and get the funding by stopping what you're doing.
Right. Let's see if there's more questions here. People are recommending you read your book, which is great.
I appreciate it.
Yeah.
I'm hoping somebody out there will make a movie.
Someone wants to know if you have a telescope. They want to know if you're an amateur astronomer.
Um, it's a little bit like my story with aviation.
Uh-huh.
I taught flying and spent every dime I could earn on airplanes in general aviation for many years, until I was lucky enough to fall into flying on high performance jets like F-18 Hornets for a living.
Sure.
And then I quit general aviation because it didn't make sense to me to pay to go 120 knots
Right.
when you're flying supersonic, and to spend money at it when you're getting paid to do the other one. The same is true with telescopes. As a boy, I had a number of telescopes and was in astronomy clubs and officer in astronomy clubs and
Very
so
good.
forth. And once I was in college, I was working for professional astronomers and planetary scientists and going to these enormous telescopes, observatories.
Sure.
And I lost interest in amateur astronomy because I got to use some of the biggest telescopes in the world.
Yeah.
So I no longer have a telescope. I have binoculars. So we went out and saw the comet, a couple of months ago.
Sure.
From our Porsche.
Those are two telescopes, so so you got two.
Refractors.
Right, right.
little bitty refractors.
But I would say that you probably have all the interest and then some that that amateur astronomers have, and looking up at the sky and wondering what's up there. You know,
I will
but you.
say, as a boy, I was famously bad at the constellations. I mean, as a Boy Scout in particular.
Oh, I see. I see. It was a struggle to get that merit badge.
Yeah,
Yeah. Right.
a lot of memorization.
Right. I don't want to ignore any other questions that might be here. Uh, a guy named Book Davies, okay, he says, in my honest opinion, Ceres is a planet. Planet is from a
Of course it
Greek
is.
word meaning wanderer. And but technical definitions, et cetera, want to exclude certain objects, and into the controversy. And I know that you're very much into um, not, I mean, the definitions that have been laid out by the International Astronomical Union don't entirely agree with your view of what a planet is. So, what do you think defines a planet?
Well, first, if you don't mind, I want to just do a little bashing.
Okay.
The IAU did in 2006 um, was, in my view, a travesty to science.
Hmm.
We don't vote on whether theories or any science is right. We don't vote on the theory of relativity. We don't vote on genetics. We don't vote on quantum mechanics. And showing the public that voting is a legitimate process in science actually politicizes science. And I think it was the worst pedagogical moment for science. And for those of you that are concerned about climate change or teaching evolution in schools and things like that, it's that kind of demonstration that science is arbitrary by voting that sets us back. And so that's the first complaint. The second complaint is the people who did it, who did the vote,
Yeah.
are not even people who are expert in the field. Planetary science and astronomy are neighboring fields. I don't know very much about black holes and galactic dynamics and
Hmm.
stellar evolution and stellar interiors, and the astronomers don't know much about planets. So that was the second travesty, was that the people who wanted to prescribe were not experts in the field and made a tragic mistake, um, which I'll describe in a moment. Third travesty is the scientific press of the day and almost ever since never looked at it critically and said, hey, we've got a problem, that requires brain surgery, and we've got podiatrists on the problem. We've got the wrong kind of doctor here.
Hmm.
They never really looked at that. So let me tell you what's actually happened since
Okay.
2006. All the textbooks now say dwarf planets are not planets because the astronomers had a vote and the press swallowed it up. But the planetary science community worldwide doesn't buy it. And we can prove that. Actually, Phil Metzger, who's a professor of planetary science and a brilliant scientist, got so involved in this problem that he did a literature search of thousands of papers in the scientific literature
Hmm.
and found not one paper on planets uses the IAU definition, except for a handful that are about the IAU definition. Everybody else in planetary science, whether they're at the microphone speaking at a professional conference
Okay.
or writing their papers, calls Pluto a planet, calls Ceres a planet, calls all the dwarf planets planets, calls the largest satellites planets. Lunar scientists call the moon a planet. And scientists have voted with their feet, and that's how science works. It's not by raising your hand and seeing majority rules. It's by one scientist making up their mind after the other until we reach a consensus independently. And with planet definition, Metzger has shown it that there's a virtual unanimity with a few rabble rousers that want to write books to the contrary, but really the literature is very clear. Planetary scientists consider anything in the solar system big enough that gravity crushes it into a roundish object. Okay?
Okay.
Unless it's the sun or, in other solar systems, their star that are doing nuclear fusion.
Right.
And so by that measure, objects about 10 times smaller than Pluto qualify as the smallest planets. You see them like Enceladus orbiting Saturn, perfectly round due to
Sure.
self-gravity. And
Right.
that's where the physics becomes what we think of as planets. That's where you see mountain ranges and tectonics and differentiation of the interior into a core mantle crustal structure, and
Mhm.
in many cases atmospheres, in many cases oceans. It's that complexity boundary that's driven by the fact that the object is large enough to operate like a planet, the
Mm.
gravity rules that makes it. And so the questioner, your listeners, exactly right. Ceres is the biggest planet in the asteroid belt. And really, the asteroid belt has very few. The Kuiper Belt has very many for technical reasons. But absolutely, Ceres counts as a planet. And so does our moon. And so do the moons like Europa of the giant planets. I like to use, and I coined this, the Star Trek test. It's really simple.
Okay.
You don't need to know any math. You don't need to have any computer models. You don't need to know any physics. On Star Trek, any one of the Star Trek series or movies, when they show up somewhere and on the bridge, the viewfinder comes on and you're
Yep.
looking at whatever they've showed up at, the audience knows within half a second whether we're orbiting a planet or an asteroid or a star or an alien spaceship, right? And you don't need any math. The Star Trek test is very reliable. Put a picture on the viewfinder, and what comes to your mind? A planet.
Ah, yeah. Do you see
When you
the
see Ceres,
horizon, the edge of
when
that?
you see Ceres,
Right.
that's all there is to it. Now, in reality, it does take one more step because you could be fooled by a little Christmas tree ornament that looks like it might be on the viewfinder. But in reality, in actual doing science, we know these are very large objects,
Yeah.
right? Thousands of kilometers across and tens of millions of kilometers in surface area in Pluto's case. Um,
Mhm.
the textbooks and the press need to catch up with the scientific community. But the planetary science community doesn't want to go out and take a vote and show the astronomers up because that would make the problem of voting in science worse. So it's going to be slow, but this tidal wave is now
How,
now.
how in the world did they ever get to the point of where it was going to be decided by a vote anyways?
They broke their own rules. They weren't even supposed to really have a vote.
Yeah.
And they voted with only 4% of their members in the room. There were all kinds of irregularities that make,
There's a small amount of people that actually did this vote. Is that right?
I think it was about, well, the IAU has like 10,000 members, or
Okay.
did maybe it's not large,
Okay.
of astronomers. And there were like, I'm going to make a mistake, but it's close to 500 people in the room.
Right.
And the vote was not that far from 50-50, by the way. It was like, I don't know, 40 something to 50 something or 40-60. I mean, it wasn't like unanimous in any means, but it was a tiny little group of whoever happened to be in this random prod meeting,
Right.
right?
Right.
In front of a television camera. It's just so crazy that the press wasn't critical of it. Within a couple of weeks of that vote, hundreds of planetary scientists signed a petition and said, we won't use this definition.
I
As
remember.
professional planetary scientists, it doesn't work. If you put the Earth in Pluto's orbit, it would no longer be a planet. What kind of legitimate categorization scheme doesn't call the Earth a planet, no
Right.
matter where it orbits?
That's right.
So, but the press ignored that too, and I don't really understand those dynamics. Why, what was happening socially? That
Right.
was like the
Gotta
story.
be one of the big frustrations for a scientist. And it is, it shows you how much more work there is to make, the world, community more scientifically literate. Because, if we reel back all of our science and saying, okay, well, maybe we've gone down this rabbit hole called science, you're going to have to give up a lot of things in your life, a lot of medicine. I mean, there's just countless things that science has done for us, and countless things that it's still doing for us. And what it will do for us. It will be through science that we'll solve our big problems, and it is only through science that we realize we even have them. So, that's that's my that's my soapbox.
And frankly,
Pittsburgh.
Everything in our society now is science, is in some way science, because everything that's engineering is applied science.
Yeah.
So everything from building buildings and roads to creating the internet, the computing revolution, communications revolution,
Hmm.
vaccine technology, everything has as its roots. I mean, you live in a house that was engineered, right?
Right.
You own computing devices and telecommunications devices, and they're all around us, and they save our lives
Yes.
in so many ways. They improve our lives. It's all based on the fact that we are inquisitive about the world and have figured a good bit of it out and turned it to our advantage, so that we have a steady food supply and longer lifespans, and we can live in a warm place in the winter rather than being freezing,
Right.
and
You
then
can
do
have
all
the
the
kind
other
of
amazing
quality
things
of
that
life that
extend
you
all the
want.
way out into the universe.
Right. Right. Well, Alan, we've been going we've gone a little bit more than an hour. Do you want to take a 10-minute break and we can come back for,
Well, good. If you are, if you want to take a break, Scott, we can.
I'm good. I'm good. But
Yeah.
if you'd like to take a break, we can do so.
Thank you for offering. I'm perfectly fine. We've
You're
got
fine. Okay. All
up
right.
to
That's
20
good.
minutes, and then I have to do something else. I apologize.
Right. No problem. No problem. So we do have a few more questions that we should get to here. Um, Ron Schmidt would like to know, are there any tools on New Horizons that will detect the heliopause in interstellar space? You did talk about it a little bit,
Yeah,
but
we have two plasma spectrometers on board that are very well suited for that. They're basically very advanced versions of devices like them on Voyager. They were built a generation later, and so they have and no exaggeration, orders of magnitude more sensitivity and capability.
mhm,
And so, if New Horizons is lucky enough to get to interstellar space at the end of its mission, and that's a bit of a horse race because we only have one nuclear power supply, and Voyager had two, and of course, with a half-life, it produces less power every year. But if we make it there, we'll definitely detect that boundary,
right,
and
right,
we should reveal new things about it that Voyager couldn't see, because of the, bless their hearts, what an amazing mission, but comparatively Stone Age technology of the 70s.
right, yeah. And plus, so the computers and the detectors and stuff, they had to be made years before they got put onto the flight.
That was
So
true.
they weren't even state of the art at the time.
Yeah, all of our technology freeze was roughly 2002.
Right.
Even though we didn't launch till 2006, we had to get it designed and built. So you have to make a technology
Yeah, and
freeze.
you can't just go, oh, let's do a little tweak here. This will make it run faster or better. You got what you got. So, um, Tracy Prell wants to know more about your flights into space. And do you think that you will only fly on Virgin Galactic, or you think you might fly on Blue Origin? Does it open up more doors for you as far as space flight?
Well, the program that I'm running, which actually involves three scientists, myself and doctors Kathy Olkin and Dan Durda, as the flyers, um, uh, has the ambition of doing space research on any
Mhm.
tool that we think is safe enough to fly, whether they're high altitude balloons or suborbital rockets like Blue Origin, or aircraft, uh, uh, rocket powered aircraft like Virgin, or others that may come along with the success of Blue Origin and Virgin Galactic.
Mhm.
We're going to use every tool in the toolkit, and we'd like to use orbital tools like Dragon and Starliner as well. Um, it's an odd thing because the space. If I can just spend a minute,
Oh,
when the space program was born in the dark ages of the 50s and 60s, um, unlike every other field of science, it was so hard to get to space that we couldn't send the scientists. We sent robots, and we had to automate everything. And
right.
automation is very expensive, and it's very failure prone. Lots of failure modes. And scientists do lots of if automation was so great, every university and industry lab would be automated. Nobody would work there. But we don't do that. Even 60 years later in the 21st century, we know that putting people in the lab just is easier than building robots to do it all in the lab.
Right.
And similarly, if automation was so great, every oil company would use rovers instead of geologists in the field, and all of the ocean-going exploration would be done with automated vehicles instead of humans on the boats and in the submersibles.
Mm-hmm.
Polar exploration would be done by rovers and other robots. Volcanologists would send rovers to the volcanoes, but none of that happens. All those fields, people go into the field, and now what's happening is in space exploration, we're at the very vanguard of scientists being able to go. And I think that's a door that once opened will never close.
Right.
Because we're going to see more and more proliferation of systems to do the space flight. They're going to go farther and farther. The scientists are going to be on every system around and in greater and greater numbers. So I think we're just going to see more and more of this, first suborbital, then orbital, then cislunar, then out to the planets. Maybe one day out to the stars. And so it's great to be at the beginning of something that, has the potential to be what they look back on in 3 centuries and say, back there at the beginning of the 21st century, that's where Star Trek began.
Yeah.
What could be better?
Right. Right. Well, I know that you're going to be in the history books as someone that they look back on as one of the scientists and researchers that started this whole thing. So
Well,
I think it's
I
great.
often say, no space flight's ever been conducted by a single person. It's a team sport.
Right.
And it's one of the most gratifying parts of a career in space flight is you get to work with so many teams of talented people and dedicated people.
Right.
And, everything from the suborbital missions that I've done where I was PI, where we did NASA sounding rockets, all the way up to, flying all the way across the solar system on New Horizons, whether it's dozens of people or thousands of people on the project, it's all about making a team work well together to accomplish something that nobody could accomplish, even the person in charge on their own, not by a mile.
There's another question about New Horizons as a spacecraft. Was there something on the spacecraft that you wish that you had put on, that you could have put onto the spacecraft, like the magnetometer, or would you? I mean, given the opportunity, would you redesign it and
I get asked that question a lot, so it's a great question. When I give public talks, which is
Yeah.
sort of this, I get asked that. Of course, hindsight's 2020. If I could have had one other thing, people say, what was the one other thing you could have? I would say I would have had 2, so that we could have seen the other side of Pluto. But
Sure.
I also like to have a bigger gas tank,
Right.
so more in the Kuiper Belt. I would like to have instruments that we couldn't afford to fly, but for the budget and the schedule that we had and the technology of the day, there was only a certain degree of miniaturization, for example.
Mm-hmm.
New Horizons did about as much as you could do for being 2 dimes on the dollar compared to Voyager, and only having 4 years to develop it, get it launched, and make it work. That's the key. It didn't do any good to just launch it. It had to work 10 years later.
Right.
So sure, there are things I wish we had more memory and faster data speeds and some sensors that, now that we know what Pluto looks like, that's what you take back on an orbiter.
Mm-hmm.
But the scientific payload and capability of New Horizons was far beyond Voyager in essentially every respect because of the march of technology. We could take a lot more data and send it home. We had sensors that were not only advanced in that they could see better, but I'll give you an example. The
Okay.
ultraviolet spectrometer to do the composition of Pluto's atmosphere on Voyager had 1 pixel. And by the time we had the New Horizons device built, technology allowed a device with 32,000 pixels.
A little different.
Okay? So you could do 32,000 times as much work per second. And the infrared spectrometer that mapped the surface on Voyager, I'm not making this up, had 2 pixels. And the one on New Horizons had 64,000. And in many other ways, the technology was just so advanced
Sure.
compared to 70s technology that we could do. I remember we actually looked at it. We said that we would do as much on the first flyby of Pluto as about the first 30 years of Mars exploration,
Hmm.
60s to the early 90s.
It's amazing the difference in technology and what you guys were able to do with it. So um, it's someone was asking also in the questions there about have you ever seen Pluto through a telescope? And the answer is yes. I know you have. I think you and your team at the time had made the best image of Pluto ever taken. With
Yeah, with the Hubble, sure,
Hubble, right?
just a blurry
It was
little
just,
bit.
and you compared that against. If you haven't seen this, you got to watch it. It's the talk where Alan Stern is at the Northeast Astronomy Forum. A fantastic talk for the layperson and for anyone interested in New Horizons. But he shows a second image, and it looks very much like the first image of Pluto, which is kind of blurry and everything. And I guess one person guessed that it was Mars, and he sharpens it up, and it turns out it's the American flag. Okay, so it was the level of detail that New Horizons brought back to us. Okay, to illuminate all of humanity about what these other worlds are like. To show these geologically active surfaces with Pluto. Who would have guessed that? You would have thought it would have been like this frozen iceberg out there. And that is something else I wanted to ask you about. That talk was a couple of years ago, anyways. What have you learned, or what has the team learned about these surfaces? Is the surface really young? Or is the science leaning towards it being something that happened many millions of years ago, or a couple of million years ago, or
Well, we're
not?
churning out refereed scientific publications at the rate of
Yeah,
about 50 a year. That's about one a week, about Pluto's interior, atmosphere, evolution, its satellites, its geology, its ocean. With regard to surface age, the interesting thing is it's not young or old. That Pluto shows terrains that were born yesterday geologically, just
hmm,
millions of years old or less, and big terrains like the size of Texas. So somehow that little planet is creating all this new stuff all the time, 4 billion years after its formation. But also we see ancient terrains and we see intermediate age terrains. And connecting those dots scientifically, that means that Pluto has been uh, vigorously active, much more active than many of the closer large planets throughout its history. And we're not really quite sure how it does that. It really is a paradigm shift. So it's got a whole age spectrum. So,
right.
whereas its satellite, the big satellite, Sharon, the one that's the diameter of Texas, um, its surface is all old. Its geologic engine ran out 4 billion years ago or a little more. And it's just in a deep freeze. It's sort of like uh, in a crypt.
That is really just a strange mystery to me that it's, I guess it's like a double planet system, right? And yet one's maybe utterly dead or nearly dead, and the other one is super active.
And I like to say um, that none of the textbooks predicted that a planet the size of Pluto could be so active for so long. But fortunately, Pluto didn't read the textbooks. It just does its own thing, and it's just rewriting how we think about the geophysics.
Right. Still going through some of these chats here. Uh, Tracy loves your explanation about what a planet is using Star Trek television series. There's many of us that are Trekkie fans. Um, I think a lot of people in our audience is somewhat outraged at the the voting process that happened during the IAU. I know that it was discussed when it happened, but and there was a lot of outrage then. And then it's like society started to, okay, this is what it is. This is how we're describing it, except for some people that dug in their heels, and you're one of those guys. So I really appreciate that.
Well, wrong is wrong. I mean, this isn't about opinion. It's about the proper science, and to try to categorize Pluto with asteroids and not with, say, the terrestrial planets is just scientifically preposterous.
Right. Right. Okay. Someone is mentioning, says, think about all those other planets that all the other planets out there that we have not yet been to. So it's great to have you on this program because I know that you're inspiring people, and that's really the purpose of these programs, is to to inspire the amateur astronomers who watch it. Many of us in this community are involved in educational outreach on a pedestrian level. Some of us get to mingle with professional scientists like yourself. I think that this fraternity or this society, this global society of astronomers, creates a thread that has really done a lot to change humanity. We try to get, in the astronomy outreach that I do, we try to encourage third world countries to get involved in educational outreach in astronomy. And we think that looking up at the stars and wondering what's out there and actually getting to the point where you start to ask the big questions, this starts off this whole process of exploration. I personally feel that that's good for you.
Well, I think that it's our responsibility, those of us who work in this, to try to engage the public as best we can. First, we need to fuel the STEM pipeline. That's what fuels the economy. And secondly, it's the taxpayers that make a lot of this frontline basic research, things like New Horizons, possible.
Mm-hmm.
And all that engagement is giving back, paying it forward, if you will, to those, the taxpayers, and to younger people who are still in school and making decisions. And it is tough to get degrees in science. You have to do a lot more homework than your average degree. You have to work a lot more hours and party a lot less. And you have to really stick with it in ways that other fields aren't so demanding. And sometimes they're more lucrative too. So, it's partially about this, but a lot of it's about this.
Right.
You have to really love it.
That's right. Well, and it does help to have mentors and inspirational people to help you get there. So I think that you're definitely one of these people. I'm going to let the audience, we're about 4 minutes out now from the time to close the show. If there are any additional questions you'd like to ask Alan, but Alan, I would ask you, what is it that you'd like to leave this audience with?
Well, first, I want to leave you with a big thank you. This is a lot of fun.
Thank you.
I was honored to be asked to do this.
No. It's really my honor. So
amazing.
Thank you.
It's great to get to know you before and now during. So thanks for all that, and thanks for the audience participation.
Mm-hmm.
But I would say to all of the people who have a chance to watch this show, that persistence really pays. And when you really believe in something, whatever your dream is or your kids' dreams, encourage them to persist even over adversity for their goal. And when people really love something and they're talented at it and persist at it, they can do amazing things. And space exploration is one example of what an amazing species we belong to, and what unlimited potential I think we have in the coming decades and centuries.
Right. Right. I believe that it's going to be an exciting adventure. We do have our big problems, but I think that we are going to find solutions to them. I think that humanity has the instincts and the drive to overcome almost any obstacle. And I do believe in the scientific process in reaching that, and dispelling, myths and as important as some of these myths might be, we need to find out what reality is, and we need to know how to deal with it, because it will make or break whether or not the human species thrives into the centuries ahead. So there are a lot of things coming through the chats for you. Alan, thank you for taking so much of your valuable time with us. That was a big chunk, and we really appreciate it. And I hope to be able to run into you again. I do want to ask you one last question. I have been talking with David Eicher and Garrick Israelian, and we are supposed to go to the Starmus event next year. And I know that you've been, and I know that Brian May has worked with you on some of the imaging aspects of New Horizons. Can you talk a little bit about that?
You mean about Starmus or about Brian?
Brian in this project that you're
Brian is an
collaborating on.
amazing guy. Super talented, historic figure in music and rock and roll.
Sure.
He started off, as a nerd, getting a PhD in astronomy. And when Queen was on the rocks after Freddie Mercury died, he wanted to go back and finish the PhD he hadn't finished. And the university offered him an honorary degree, and he wouldn't take any part of it. He said, no, I really want to do a PhD and a dissertation the honest way that I started it.
Mm-hmm.
So he earned a real PhD. Not that honorary PhDs aren't earned, but he earned it in the traditional way. And then Queen has had this amazing resurgence in the past 15 years.
Right.
At the same time, Brian has gotten involved in New Horizons and now other space science missions.
Mm-hmm.
And he's just a great, really down-to-earth person, very humble. I remember I was in London to give a talk for the magazine New Scientist, just a public talk.
I'm familiar with the
A couple
magazine.
years after New Horizons, and my assistant wrote Brian's assistant and said, any chance Brian might want to get dinner? He's only in London for 2 nights, but either night's open.
Yeah.
And Brian said yes, and then we got to this little vegan restaurant over at the West End, that part of London, and I showed up after he did, and I walked back to the table in the back of the restaurant, and there he is with his laptop out, analyzing data.
Cool.
I said, I come unarmed. What are you going to do?
Right.
This is a working meal. I thought we were just going to shoot the breeze and talk about whatever.
Right.
And he's a wonderful guy. He's very interested in many causes, mostly causes to do with the Earth, and not just the Earth as a planet, but also, for example, the species on it. He's particularly interested in animal welfare. So I had nothing but great things to say about that guy as a scientist and as a human being, and of course as a rock and roller.
All right, of course. Well, gosh, thank you so much. Yeah. Well, Alan, thank you so much for joining us. And again, I hope to run into you or meet you or have another talk with you. And until that time, we'll see you. We'll see you on social media. And by the way, I also wanted to thank you for all that you do on social media. You're a very busy guy, and to spend that kind of time out there and to be so accessible is really remarkable.
It's all part of that engagement thing. With
Yeah.
apologies, my phone is ringing on silent, but I'm going to have to take it.
No problem. Okay. We're all done here.
Thanks
Thank you
for
so much.
having me on.
Thank you. Take care. Bye-bye.
You know.
Bye-bye.